All right. So in the last class, we talked about what is LangChain. LangChain as a framework. Why did we use it? What are the different components? What is the ecosystem? And what are the different libraries? We use LangChain core. We use LangChain itself and LangChain community. And we have also seen that we have dedicated packages for big LLM providers like OpenAI and Google as well, right? So, and we also saw, what are the different type of objects we have in the LangChain, how to connect with the LLMs, what are different prompt templates, what are messages, things like that. So today we will go one step further and we will see some advanced concepts in the LangChain. Okay. So before that, let's have a quick recap. We have seen the fundamentals of AI, machine learning, deep learning, generative AI, all are different ways of machine learning, right? Artificial intelligence and machine learning. Deep learning is also a machine learning. Gen AI is also a kind of machine learning. In the week 2, we studied about the different large language model based applications. What is client? What is server? We have seen that LLM is just one of the services when we build applications. We also saw in the last session how to use the LangChain. And in one of the lectures, we also saw how to set up local environment. Okay, so this is what we have done. So now in this module, we will see how more sophisticated chains or more complex workflows can be built, how we can monitor our application in the LangChain. And we will also do two small projects where in one we will develop conversational chain and other is the complex chain where we will build some application which will create a Wikipedia post, okay, out of some Wikipedia. It will generate one article out of Wikipedia article. Okay, you will see in great detail. This is what we did so far. We have variables. These are all called as the components. LangChain components. We have prompt templates. We provide values to these prompt templates. They produce prompt value as an output, which is passed to the model. Model generates AI message, and it is passed to the next component, which can be string output parser or JSON output parser, and we receive the text. So this is the overall flow. And we have also seen how to build a chain out of it, right? If we stitch all these components together to accomplish something, then we start calling it as a chain. In this lecture, we will see what is LangSmith. When we saw the ecosystem of the LangChain, we have seen that there is something also called as the LangSmith. There was LangChain, there was LangServe, LangGraph, and finally there was something called LangSmith, which is we are going to study today. So we'll see what is LangSmith, how to use our own functions inside the chains. So far we were seeing how to put LangChain components with each other. But what if I want to plug in one custom function, right? My own function, which is doing some custom action. Maybe it is calling some tool. Maybe it is going to weather.com API, whether it's going to DuckDuckGo search, right? Maybe it's going to update some database, anything custom which I want to do that I can plug in my chain also. So that's very important. And runnable parallels, compose chains, runnable pass-through, and memory conversation chains. Okay, so these are few topics which we are going to study today. Any questions, guys, before? All right. So let's jump to LangSmith. So LangSmith is an observability tool or platform developed by LangChain itself. So when the LangChain people saw, their product is getting very famous and this LLM concept is also getting famous, more and more companies are using or building LLM based applications and they are also using LangChain. So they came with this another offering which is called LangSmith, because it's very important to find out what is going, or how to debug your applications basically. So what LangChain helps with, it has key features like it will help us to track all the requests to the LLMs. So whenever we are sending any request to the large language model, it basically track all those requests. It allow us to monitor all requests sent to large language models within your application. Second is monitor data flow within your chains. As I said, if you build some chain like this, and if you need to monitor what value is going into my one component and what is coming out of my same component, and then what is going into my second component, right? In order to debug my application, I should know what are those different values. Otherwise, what will happen in my piece of code, I will just give chain.invoke and I will pass my input parameters and I will receive my output. So there is a lot of abstraction going on. So if something goes wrong, I should know how to track my application, how to see where is something wrong is going on. So in order to do that, in order to track all my requests, all my values which are flowing within my chain, I can use LangChain basically. I hope it is clear. Okay, so monitor concurrent operations, to monitor token usage. So once I will log into this LangSmith, I think most of these points will be further clear. So overall, LangSmith provides valuable insights into the usage and the performance of your LLM within your applications. So it will also tell me how many tokens have been consumed for this request, input tokens, output tokens, total tokens, okay, things like that. And these are basically the features that what LangSmith provides. But the question is why? This is what basically. And this is why we should monitor LLM applications. So as you already know, this LangChain and this LLM concept, LLM itself is very non-deterministic. So if you are receiving some response out of large language model, you cannot argue why this response has come out of this LLM, right? Because it's basically a black box. How that response has been calculated, how the next token is calculated, we know the concept, but how exactly it is done for a given instance, we actually don't know. So LLM itself is a black box, or it's very non-deterministic. And again, what we are doing, we are building applications using LLM. Thus, it becomes even more important to know at least what is going outside the LLM, what is exactly being produced by LLM. Is it a string? Is it a JSON? What are the values? Is it parsing correctly or not? Right? For example, if this is a user, if he's sending a request with to the LangChain, the chain which we have built using different components, there may be a lot of things going right. That information is getting passed. There are lot of large language model calls. Maybe we are using two different LLMs, so the calls are going to the two LLMs. There are data transformations, right? There are retrievals. If we are using vector databases, we are retrieving the values from the database. We are doing API calls. So there are a lot of things which are going inside our chains before we get the response. Otherwise, what will happen? We will just send the request and we will receive the result or the response. Now, with the help of this LangSmith, I can actually deep dive into what is going inside my chain. I can see the parsing, LLM calls, transformations, each and everything to debug or track my application. Track complex workflows with the multiple API calls. Concurrent makes it easier to diagnose and optimize LangChain. I hope it's clear why do we use LangChain. Now let's see how to set up it. Its setup is very easy. Yeah. Anyone unmuting
Yes,
and
sir.
try?
One,
Yeah.
one question.
Hmm.
Like LangSmith is like have a out-of-the-box connectivity or integration with LangChain.
Hmm.
With LangChain, can we integrate other tools, market leaders in observability like Elastic or Datadog or some others?
I have to see. You
Okay.
have to see the documentation of those products where, I mean, whether they are compatible with the LangChain or not. But yes, you can use LangSmith with or without LangChain. It's not mandatory that you should be using LangChain in your code, and then only you can
Mhm.
use LangSmith. So you can use LangSmith even if your application is not built in LangChain.
Okay.
That I know.
Okay. Okay. Thanks.
Usually, what we do in the industry is we use custom logging, right? We write our own logs so that those logs are produced
Right.
on the platform itself, or maybe in some flat files, right?
Yeah, because
Even.
most of the time,
Mhm.
like organization have their enterprise standards to like all
Correct.
these logging.
Mm. So in the projects I have worked, we have dedicated methods for calculating the token cost. We count the token and then we calculate the
Okay.
cost, right? So all those things.
Hmm.
Because I think LangSmith is a licensed product, LangChain is open
Open source.
source.
Okay.
Okay. So let's see how to set up this one. Let me open VS Code. I have activated my virtual environment, and let me take you to the official documentation. If you go to LangChain website, you can go into docs and LangSmith. So you can see this is analyze traces in the LangSmith and configure metrics dashboard. So now what they are doing is day by day, they are also improving LangSmith, and they are also adding a lot of other offerings within the LangSmith. For example, they have evals, evaluate your application over production traffic, prompt engineering. You can create some prompts, things like that. Okay, so day by day, they are also adding a lot of things in this platform. So what we need to do is, where is a quick start? Quick start, okay. Observability quick start. And what we need to do is we need to install this package, which is called LangSmith. So we have activated our virtual environment. Let's install pip install LangSmith. LangChain we have already OpenAI and LangChain we have already installed. What after that we need to set these keys basically. Okay, so before doing that, just type LangSmith keys. Okay, I will create API key. It also asks about when your key should expire. Its default is never. So I will click on create API key. I will copy this API key. I will go to .env file. I will paste it. So I see what I need to do. LangSmith underscore tracing as true. LangSmith API key. And let's take all these things and put it inside our .env file. In the .env, we know the format is like key and value. So I will remove these exports. This OpenAI we already have, so I can remove this one. This key I will cut and put it here. Okay, so these are the two properties. All right. So I have set my .env file. This is my advanced file. Okay, go back to my documentation. All right, define your application code. Then I think your routine code will work, right? So what I will do is let's build a small chain. My first step is to import OS and to .env, load env. Okay, load .env. What it will do, it will basically load all my .env variables. Okay, stop me anytime you feel that you are not getting. Okay, this we have already discussed although. So I have loaded my .env file. Now I need to do from Langchain underscore core dot prompts import chat prompt template from messages, AI messages from Langchain underscore OpenAI import chat OpenAI. Okay. So from this, I will get my model. From this, I will get my prompt template. The third component is usually your parser. So I will do LangChain core dot parsers output parsers import string output parser. Okay, I have done that. Now I need to create my. So I'm just telling you all these things, showing you all these things so that you are never stuck, right? And you never need to remember the code. So just go to LangChain again, go to LangChain documentation, go to how to guides, tutorials, get started, conceptual guide, it is LangChain. Integration, sorry. Within the integrations, I can go to OpenAI installation and setup. This we have done, chat OpenAI and chat models. Anyways, what I will do now is model equal to chat OpenAI, model name, temperature, maximum tokens, string streaming. Let it be. I will close now. This is my model. Now in the prompt, let's say my prompt is chat prompt template from messages from template. My simple question is, you are a helpful assistant, answer the following question. Okay. This is my prompt template. My parser is like string output parser. Okay. So this is, I have instantiated all the three components. Now I need to build a chain. Chain equals to prompt model output parser. Let's see. Now result equals to chain dot invoke. Invoke with what? My prompt is looking for the value for this question, right? So I can simply pass one string saying who is president of USA maybe. Okay. Okay, let's see. So as per my last update, the president of United States is the Joe Biden. Okay. But this is not correct, right? Because there is some cutoff date for large language models. So now let's go to my this platform, which is called LangSmith dashboard, maybe. Today is 27, right? So if I go into this page, what I will see is my different projects are there. So there is a provision where I can give the name of the project. So if I, for example, earlier I worked on certain AI labs, demo ALC, demo project, right? So this time I have not given any name. So my all my logging will go into default project. So if I click on that, you will see runnable sequence. What is runnable sequence, guys? Runnable sequence and chain are same things. Okay, so they are used interchangeably. So if I click on that, I can see my request. So this was my request. Runnable sequence. Do you know, guys, runnable sequence and chain are same? Let me iterate once. So these are different runnable components, right? We talked about what are runnables in our last lecture. Runnable are the components who implement or who use the interface, right? This interface, this runnable interface make us easy, and they expose same set of methods for different components. That's why we can do prompt template dot invoke, model dot invoke, output parser dot invoke also. So the same methods are exposed by different runnable objects. Prompt template is a runnable, model is a runnable, even the chain which we build, that is also runnable, right? And this is what we have created chain by stitching together the different components. Since these are runnables, this chain is also called as the runnable sequence because it's nothing but the sequence in which we have put these runnables. Is it clear or not? So this is just a term that technically this is a runnable sequence, but in general we call it a chain. Okay. So if you
Those
see,
sequence,
yeah,
those sequence are component, right?
correct. These components,
Okay.
they are basically runnable. So when I put runnable in a particular sequence to build a chain, then I call this chain as a runnable sequence. Okay. So runnable sequence is equal to runnable chain. Both means the same thing. That's what I'm saying. The documentation earlier use the chain word. Now they have started using technically Langchain runnables. Runnable sequences basically. Okay. So this is one runnable sequence, right? So that is the reason why you will see here this is a runnable sequence. Okay, in our code we have written this chain, right? This chain is a runnable sequence and it has three different runnables. right? So that's why it's showing me a runnable as a top layer, and within that runnable on the chain we have three components. So when I click on the runnable sequence, I will see the input. My input question was who is the president of USA, and this is my output, right? As per my last update, this guy was the president of the US. Now, if I want to deep dive, if I want to see what is going inside my chain, I can see there are three different components: chat prompt template, the model, and the string output parts. This is exactly what we have in our code. We have the prompt, we have the model, and we have the output parts, sir. So now if I click any one of these, I will see the details of that particular component. So what is going inside my first component? This question. What is coming out of this prompt template? You are an helpful assistant. Answer the question, who is the president of the USA? Okay. So it is showing me the input and output of my first component, and that was my main intention. Right? My question was, who is the president of USA? When I invoke my chain, this question goes to my prompt, and my prompt was, you are an helpful assistant. Answer the question, and it will basically this question variable will get replaced by this sentence. Okay, so that's why it's showing us the entire full prompt. Clear है सबको? Is it fine, guys? Yes, no, समझ में आ रहा है नहीं आ रहा?
Yep.
Yeah.
All right.
Yeah, this is fine.
So now this output of my first component will go into as an input to my second component. This is my chat OpenAI. You are an helpful assistant. Answer the question, who is the president of USA? And this output is as of my last update, the president of USA is Joe Biden. Okay. This is my output. And if I click on the string output parser, I will see what has gone into it and what has come out of it. Okay, so this is overall, right? So if you see in the right hand side, it will see how many tokens used 0 for this component. For this component, it will say the input tokens were 67 and the cost was also involved. This much dollar was the cost. This is the latency. The type is LLM. These are the tags basically. So you can see, you can capture the start time, the end time, the API call, whether it was successful or not, right? Now, number of tokens. So there are a lot of details which are present in this particular platform. And that is the reason why we use it. If I click on runnable interface, you can see right under it, the total time for the entire sequence, 1.67 second, and total tokens are 67 tokens, out of which my prompt tokens are 25, my completions are 42. Both input tokens and output tokens, they have different rates basically. So that's why they have shown the different prices. Okay, they are charged with a different rate. I think input tokens are cheap and output tokens are costly. So we have to optimize them. Okay, clear, guys? This is the beauty of LangSmith.
And Surendra, it's automatically calculate the rate based on to the model
Yes,
offering
yes,
or how
yes,
it's
yes,
calculated?
yes, yes.
Okay, so basically, if I use Grok, it will automatically consider that cost.
Correct. Grok is open source, so I think it will just show the number of tokens used, no price.
Okay.
Okay. Even in the code itself, what we do is in my office, if you are using any model, so I will go to the Azure portal. I will see which model we are using, and in its documentation right there, they will show the cost of input tokens and the output tokens. So I just calculate the number of tokens in my logs and I do some maths to get the cost for that request. Okay.
Okay.
All right. So that was LangSmith. So this we have done.
Surendra, can you show the code once?
Yeah. So now you may be surprised, right? Why this is not giving me right answer, whereas ChatGPT does give me the right answer. Correct?
Yeah,
The answer is these large language models, as we have seen in our first or second lecture, right? They are input output machines, and we usually train them, right? And at some point of time, we have to stop the training, and then that model will be put for the uses. Yes or no? So when it was trained, there is always a cutoff date when the training stops, and we and the release the model for the use for the applications. Beyond that, it's not being trained. But ChatGPT is what? ChatGPT is not just an LLM. As I said, it's a web application, and this application is also using different tools like web search and other things. Okay, so when you ask a question in the ChatGPT, it basically sees the question. It will go to the web search. From the web, it will see, okay, the president is Donald Trump, and then it will fetch the answer. Okay, so that we will also see how we can use the tools like Wikipedia or maybe some Google search or some DuckDuckGo search to pull information from the internet. Okay, so these chat GPT applications are basically agents as well. So you have seen in the last week they have also released that agent functionality. So in your for the pro and these users, they can actually, so if I go to chat GPT, so if you click here in the tools, what are tools? Tools are basically certain functions or the methods which we expose or which we give to the large language model. This we will see in the agent section. Okay, so LLM basically work as an agent as well. We build some agentic applications where LLM is provided couple of custom functions, right? They are also called as the tools. So once the LLM knows, okay, I have these tools, for example, I have a calculator, I have a weather function, I have some web search function, and when you ask some question, then the LLM will decide if that question can be answered with the help of those tools or not, right? That's why we say it basically that logical thinking and reasoning is now put in the large language models, and that's what the agent is. So they will think, okay, this guy is asking me the temperature, then they will use weather API. So they will forward that question to the weather API function. That function will go and it will invoke weather API, and it will fetch the answer, and it will give back to the large language model. And the large language model will then have the right information with it. It will synthesize the final answer, will give it back to the user. Okay, so here you can see you have something called think for longer. You have deep research. This is also what? This is also an agent. Okay, create image, web search, right? All these are basically different agents. Now they have another option which is called agent itself, just agent, right? So that agent is basically a combination of their deep research, and there was one more agent which was released in January that is called assistant. Okay, so that agent will do what? If you say, I have to go to Bangalore, I have a conference, okay, book my tickets and things like that. It will basically uh, think about your question. It will split your question into different tasks, and then, okay, it will see, okay, he's going off, he has to go to Bangalore for some conference, Bangalore's. It will check the weather of the Bangalore. It will see, okay, there may be some rain on that particular day, so it will suggest some outputs for you. It will book the conference room, it will book your air tickets, it will do cab booking, everything it will do, right? So this is called agents who are basically autonomous. We give our instructions, and they take our with the help of those instructions and our prompt, they will do lot of things. They will also tell you the new agent which has been released 2 days back. It will also prompt you to put your credit card details, right? It can, show you all the things on the screen itself, how it has, reached to a particular conclusion. I mean, it's very powerful, but at the same time, the OpenAI people also mentioned that you should use it with caution, security, because there are a lot of hackers. If you're putting your credit card informations, be mindful, right? So there are a risk involved as well. Okay, so if you see,
Surendra, one question.
Mhm.
So all these five functionalities that you showed, if we want to use them as part of the LLM functionality, LLM based functionality we are using, let's say on our website, any website, then they have to be included separately. Like they are not included by default. Like
Correct, correct. So right now we are just using LLM, right? So whatever question we will ask,
yeah.
it will come only from the LLM's knowledge, right? And the LLM has limited knowledge, so it has not given. So if I want to use some other search also on top of it, let's say web search, then I have to add those components into my request.
Okay, okay, and
Okay,
then they will charge us extra for that,
exactly.
and
For
that we
example,
calculate using LangSmith, that how much they are charging.
yeah,
Or
I mean, you can go to their documentation as well. They will say for each API call, they will charge something, right,
okay,
as per the request. So last week I was trying on the OpenAI. Uh, OpenAI has something called the Bing search with the grounding. Okay, let
yeah,
me show you. So let me show you first this announcement, right? I want you guys to go through. Okay,
okay,
introduction to ChatGPT agent. So once you have some time, go through this video, which is released just 2 days back. It will give you some idea. Okay, what are these agents basically? And then, okay, Azure, Azure Bing search API. So what we were doing is we were using SERP API. So there is something called as the SERP API. Okay, so this is being used for s- Google search basically. So we were using Gemini model. We were using, I think, 2.0. Okay, so we were using Google's Gemini model, and we were also doing some internet search. So we were using SERP API for that. But then the accuracy was not good enough, right? So we decided that the combination of Gemini and the SERP API is not giving us good results. So we tried to switch over to the OpenAI model, which is deployed on the Azure. So there, since this is a Microsoft platform, so they have these OpenAI models, but there was no as such SERP API, right? So there was another option which is called the Bing search, right? So they have this search engine as the Bing search. So that Bing search we can use for doing the web search. Okay, it has cost like, for the 3,000 calls, first 3,000 calls are free, and then each search call will cost you some dollars. So like that, they have their own models or their own costing models. Okay, so you can use all these things. And there is also something OpenAI web search. OpenAI web search. Okay, so if you are not using any platform, right, or any Azure or Google, so what you can do is you can also do right with the help of OpenAI models also. They have called web search, right? So if you go to the documentation of OpenAI, on the left hand side, you will see web search options, right? You have to do the same thing. You have to define the model, and then in the web search option, you have to put the user location, what type of search you are doing. Is it an approximate? There are 2, 3 type of searches, right? Where it is. I wrote an article actually about this one on Medium, and then approximate the country. So you have to basically provide some options to the web search so that that search is very much focused as per your requirement. Okay, these are the high, medium, low values. So this high, medium, low will also decide your cost. Okay, search context size, right? Okay, so you can go through this one as well if you want to do the web search right away. All right. Since we are not using, so it's just using the LLM knowledge. Okay, let's go back to our deck. This we have seen. Okay, this thing I was telling you, runnable sequence and chains, they are same basically. Okay. Using functions. So let's talk about how we can use the functions inside the chains. So this chain we have already seen, right? Now, if you want to put a function call in between, what are the different ways? So integrate custom functions into the runnable sequence, use custom functions within the chains, function interact with the external services or perform actions, perform some operations, prioritizing chain over the agents when possible. Okay. So this is quick introduction and this is an example. So let's say in this chain, we want to invoke one function as well. But the problem is, as per the syntax of the Langchain, whatever components we have in the chain, they all are runnable, right? Prompt is runnable, model is runnable. So how to make this function call as a runnable? So the simple uh, solution is that by using lambda expression. So what is the lambda expression? With the help of lambda expression, you can just give the input in the left hand side and in the right hand side, the name of your function which you want to call and its input parameter. So it will produce some output, right? That output will be used as an input to my next component. Okay, so this is also called as the coerced function. So by using this syntax, we can do our custom function call within the chain itself. Okay, and this expression makes it compatible with the Langchain expression language of my Langchain. Okay, integrate external functions into the chains. Functions behave like runnables in the sequence, ideal for interacting with APIs or custom logic. Okay, is it clear? So let's do it. So let's write some function and try to do it. So let's say this was my chain and I have some function. Let's say point uh, definition, let's say city temperature. Tell me. Okay, I have written this simple function. So what it will do, once I give city as an input, it will tell me the, or let's say get weather instead of get. If city dot lower is this one, okay, or we can simply pass. Okay, so this is the small function I have written. And let's change our prompt to your weather assistant, provide the weather of the city. Okay, this is simple. I will bring my chain. Okay, so this time what I need to do, I want to plug in my function also in the chain. So its syntax is like lambda city get weather city. Okay. Is it right? Okay, so I have used this lambda function and I'm invoking this function. I will pass the city. It will give me temperature of that city and that you are a weather assistant, provide the weather for the city. Okay. This is giving me the weather now. Okay. So this will give me the name of the city. I will pass the name of the city. It will give me weather and this weather will go as an input to my prompt and it will suggest me what I should wear. Clear enough, guys? So let's invoke this one now. Chain dot. What I should pass? I should pass the name of the city. Okay. Let's see. If the weather is sunny, here are some output suggestions to keep you comfortable and stylish. Good enough, everyone? So this is how you can basically plug in your custom functions within the chain. This is called coercing a function, right? Or making the function runnable with the help of lambda expression. Any questions? I will show you. I have some piece of codes. Okay, I will share that. You can practice more on that. So this we can also do with the help of Grok. Okay, so you can try with the Grok. The only thing you need to change is model equal to chat Grok. Okay, rest will be the same. Now there is something called the runnable parallels. So just like we have created this particular chain, right? We can also create a chain where two runnables can be executed parallelly. Okay, runnable 1 and runnable 2. And whatever output we get out of these two runnables which are running in parallel, I can club them those into some dictionary and that dictionary can be passed to my prompt template. I hope you remember, right? If you are having multiple variables in the prompt template, I need to pass the dictionary as an input because otherwise it will get confused. If I have just one variable in the prompt template, I can simply pass the string. If I have more than one variables in my prompt template, I need to pass the values of those different variables with the help of dictionary so that it basically knows into which variable which value is to be passed. And dictionary is nothing but what? It's a key and value pair. I will show you in the code in some time. Okay? So those two runnables can be executed in parallel and they will produce some output. It will create a dictionary and it will go to the prompt template. The prompt value will be created and then LLM and output parts are. So what are runnable parallels? A dictionary of several runnables. All runnables in the dictionary are executed at the same time. Takes as an input the union of input of all the runnables in the dictionary. By the way, I just forgot to show you the output, the previous output in our this one. LangSmith. So if I go back, this is my, okay. So this is my runnable sequence, my chain. Now it has 4 parts, 4 components, right? Runnable lambda, which will show input and output. I was invoking one function, input was New York and output was Sunny. And then this you have already seen. That Sunny is now going into my prompt template. It's creating this prompt and other things. Cool, guys. So overall, it took 6.53 seconds and 308 tokens. All right. So let's see an example of running runnable parallels where we execute 2 different runnables in parallel. So in the first step, instead of one statement, what I can do, I can have 2 lambda expressions. That means now I can give my input to these functions simultaneously. They will produce some output. And as I said, now it's necessary to put them in a dictionary format. So my key is weather. My second key is temperature. Output of my first function will go into my weather key and output of my second function will go into my temperature key. And both these keys or this entire dictionary will be passed to my next component. My next component is what? It's a chain now. So what I have done, I had those 3 components, I clubbed them together and created a different chain. Now I have 2 chains. This is the compose chain, which is invoking another chain, right? And the first component of this chain is my prompt. And this prompt, if you see, it is looking for 2 values, weather and temperature. I hope this is clear, everyone.
So in this case, this lambda input like get weather and get temperature will be executed parallelly.
Exactly. And the values will be stored in these keys, and that dictionary will be passed to my chain.
Mhm.
Chain's first component is prompt. This prompt will set weather value and the temperature value out of that dictionary.
Okay.
Right?
And it's automatically managed by the inline these code that first function might take few millisecond, another take maybe greater time. So it will the chain will be executed once all these will be completed.
Correct. Okay. And the most beautiful part is now these components or these runnable parallels, they can be anything, right? They can be chain also. This can be chain 1, this can be chain 2. Are you
Okay.
getting
So
any component which is
mhm.
a runnable can be here, right?
Okay.
They can be retrievers, they can be LLM clients, chains itself, cohost functions. These are cohost function right now, right? So they can be
Mhm.
literally anything, chain 1
Yeah.
and chain 2 as well. So now you
Yeah.
can just think how complex workflows we can build using this syntax. This
Mhm.
is so powerful.
Yeah. We can like call another prompt and get the input and then wait and
Exactly.
then press on.
Exactly. So when we create these applications, right, end of the day, there is just one function which we need to call. So that function will be basically our compose chain, right? The user will be passing some parameter, and on the basis of that, all the things will get executed, right? And you will get your response. Okay. So so much complications have been just tackled in few lines of codes, right? So we'll see all these things in action. Let's go. Okay.
Just one more question. So how do you decide which one to execute first and which one to execute
So that depends on your application logic, right? What logic you are writing, right?
later? Okay.
As per your requirements, you have to build all those things. So right
No,
now,
so suppose
hmm.
if you so if it is is it a priority basis? Is it some kind of like if you have say temperature and weather, right? These are the two different functions, right?
Hmm.
So if I call temperature first and this one later, uh, so will it make difference or it will
No,
just
no. For
use
this
it what
present, yeah, I
in
mean
the prompt?
for this present case, it will not make any difference because our output of this is anyway going in the dictionary. So this prompt will figure out the value of weather. Okay, it will search for the weather key, and it may be in the second second in the sequence. Still, it will be able to get the value. Okay, so it does not matter anyway. These are executed parallelly.
No, but these are dependent. Means I think these need to be executed first before the actual prompt needs to be executed.
Yeah.
Right.
Correct.
So they will always take preference, right? Means in terms of, suppose you said that we can have chain within a chain as well. In the composition you can have a chain, another chain, right? So that needs to be executed first, and then that will be passed into this composite chain.
Yes,
So
yes.
how that means that based to totally depend on the what I call logic of a program, how we have to call it means.
Yes, I mean, so all these things are internally managed by the Langchain code. Okay. So until and unless all these runnable parallels are not executed, it will not proceed for the prompt. It will wait till the last request is executed. Once it is done, once that dictionary is ready, then only it will pass it to the prompt basically. Okay.
Okay, and in this in your what is called so this all this will be we can see in the dashboard that how this is getting executed.
Yes. That let me write the code first. Okay, and then I will show you. So instead of writing the code, let me enable parallels. Let me copy paste it. Okay. I have to do some modifications. Or I will take this one as let's. Okay, so what we have done now, we have two functions. One is get temperature, other is get weather. This is looking for city. This is also looking for city. This is my prompt. Weather is, temperature is. This is chat grok. Let's change it to model. This is my parser. This is my prompt. Compose chain, weather, the code which I showed you in the deck. Let's execute. Something has gone down. What should I wear? Weather. String output parser is not a polyable. What does that mean? String output parser should be string output parser. Okay, if the weather is cloudy and the temperature is 15 degrees Celsius, it's generally mild but can feel blah blah blah, top layer, bottom layer, whatever it is. So if I go back to my platform, this is my runnable sequence, and now I can see this is my top chain. If you see, it has taken 3.26 seconds to 59. Within my chain, there was a runnable parallel. So that's why you can see, right? These are written in the parallel. And it took 0.0. If I click on that, it will show me the overall. The output, the input was Paris, and my output was weather and, sorry, cloudy and 15. Right? If I go inside into each runnable lambda, it will show me its input and output. It also tells you how much time it has taken. Chat prompt template. Now you can, just think or appreciate how useful this LangSmith is.
Surendra, this temperature is calculated based on the this input whether we provided, right?
Correct. This is, the city was Paris, so it's 15.
Okay.
City was Paris, so the weather was cloudy. So both things were passed to the prompt, and then it calculated. Okay, looks good. So I was saying you can also put chains, instead of these, any runnable components you can put, right? So let me see. I think I have some code for that as well. Runnable pass through two chains. It should be the code. Two chains. This is my first chain. Write a poem about this topic. So I have prompt template. This is my prompt. This is my output parser, and this is my, and let's copy. So, okay, this is my poem chain. Okay, this is my first chain. So what this is about, if I pass some input, let's say coffee, this, what it will do is it will write a poem on the coffee. So in the quiet dawn, a gentle brew, a dance of stem, a morning's cue. Okay, so this is a nice poem. Similarly, what we can do, let me close these. I have another chain now, which will write a story about the topic. Let's put it here. Should work. It's taking time. So this is the story. Once upon a time in a quaint village. Now I have a third chain, which is called comparison. Okay, this chain will do what? It will basically compare the story and the poem, the output from the earlier two chains. And this compose chain, now what we are doing in this runnable parallel, we are passing these chains. This is the poem chain, this is the story chain. Once we give the input, they will generate some output. Those will be stored in this dictionary. That dictionary will be passed to my comparison chain. This comparison chain has a comparison prompt, which is looking for a prompt comparison template. It has two variables, poem and story. Okay, all good? Determining the better quality between a poem and the story is inherently subjective. It's giving the disclaimer, okay? So this is poem analysis and this is the story analysis. And this is the conclusion. It's appreciate, concise, it if you prefer a more detailed. So now you can, see how complex things we can make with this Langchain framework.
So the use of dictionary is to decide the sequence, like which chain will be, or which attribute will be used first.
No, it's not like that. The thing is, I shown you in the Langchain documentation. If I just give me a second, I'm getting a call. Just a second. Where is the mute button? Sorry, guys. Okay. So what I was showing you, yeah, I was showing you that particular. Just a second. So I was telling you that dictionary is basically not telling me the priority, but that's a format to give the input to my prompt template. Okay, so we have seen in the runnable section, conceptual guide. If I go into runnable interface, this table, right? When I talk about a prompt, its input is basically a dictionary. Okay, so if there are multiple variables in my prompt, and if I want to give the values for those variables, I need to put it in some dictionary, right? Otherwise, how it will come to know? Or let me show you. This is your question, right? Let me show you a prompt. For example, this is the prompt, okay? Prompt is write a story about topic and then write a poem on this topic. Okay, so there are two variables, topic and topic 2.
Yes.
So if I execute this, if I want to do something like prompt underscore, so this is just prompt template, right? I need to convert it into chat prompt template, and this prompt template I will provide. This is my prompt. And if I see prompt dot invoke, so now I need to provide these two values. So what are the options for me to provide the values? If I pass a single string, that will not work, right? So I have to explicitly tell what is the value of topic and what is the value of topic 2, isn't it? So I need to pass a dictionary. This
Okay.
is what you can see here, right? The input for the prompt is a dictionary, and it will generate a prompt value. So if I pass these values and execute, I will get this value, right? Chat prompt value. Write a story about coffee and then write a poem on this topic, coffee. Getting it? It can be anything, right? Can be
Yes.
tea or something.
That will depend on user input, right?
Yeah. So same thing if you want to do in the chain also, the component which is coming before this prompt is basically our runnable parallel. So the output of the runnable parallel should be in the form of dictionary. So the same can be passed to this component, this prompt basically. Okay. And this is good enough. Runnable pass-through, there is another concept which is quite difficult to understand, but runnable pass-through are used to pass the value of a previous step in a chain to the next step without modification. Okay, so let me tell you, let's say in this chain, okay, in this chain there is just one chain, let's say, okay, and the second value for this prompt, I want to pass from the user input. Then what I have to do is I have to give my dictionary as an output, right? So I can write here one runnable pass-through statement. Let me show you with the example, otherwise you will get confused. This is runnable pass-through. Do you want me to execute this one? Let me just first explain you. So in this case, this is a prompt, right? So this prompt is having this template. This template is looking for two values, context and question. Okay, this context we can get from the retriever. Or let me try to execute this one, otherwise you won't be able to understand. Command. This is FAISS. This is Facebook similarity search vector database. Okay. Integrations. If I go to vector database, vector stores, there is a vector store. We are using OpenAI, and we are using which vector store? FAISS. Facebook. What is I? Facebook similarity search. Facebook AI similarity search. Okay. So for this, what I need to do, from Langchain community import. Okay, I think this library is missing. So let me do pip install Langchain community and these as well. Okay, so these are additional libraries which we need to install. What it is saying, could not find a version that satisfies the requirements of FAS GPU. So I'm using this Copilot assistant. Let me ask, explain the error. We have done right. Sticking time, what happened? something wrong. So meantime, let me explain you the code. So what we are doing is we are basically using this doc store in memory vector database. Okay, so vector database is what we will cover all these things in our next to next lecture, where we will study about RAG, retrieval augmented generation. So there, what we do is we create some vector database and we store our documents there, right? So that's why we are importing this in memory doc store, and then we are using these libraries. Something has got messed up. This is done or what? Okay. So let me fix the code. I don't want to use Grok. This Hugging Face. I can use OpenAI embedding as well. Embedding model, OpenAI. Okay, so in this, I'm actually using the embedding from the Hugging Face. So let me see if I can use embedding of from OpenAI. Okay. Vector store. Delete this one. This may take some time, guys. It's
What is this embeddings?
Embeddings, I will explain. So whenever whenever we implement RAG, right? RAG.
Yeah.
So if we have our own documents or repository and we want our LLM to work on top of that, right? For example, if you are working for TCS and the TCS is having a lot of policies, if you want to build an LLM, a chatbot on top of your own documents on which your LLM is not trained, right? Whatever internal policy documents are there, whatever leave or the promotion policies you TCS guys are having, on that data, your LLM is not trained. So it will not be able to give you those answers. So what you can do is you can take all the documents, your own documents, and then you can create a vector database out of it. That database, which during that process, it will, whatever policies you have, it will chunk that into different smaller portions and it will create embeddings out of it. Okay, so I will explain all these things in our next to next lecture when we will study about the RAG. But for the time being, just keep in mind, if you want to do some question answering on our own data, we have to take our data, we have to parse our data, and we have to create embeddings or vectors. Okay, and then we have to store those vectors in a vector database. So right now we are doing same. We are using this embedding model from the OpenAI. Right? We will use OpenAI model. This model will help me to create embeddings out of this sentence, this single sentence, and it will store them in the FAIS vector store. Okay, so don't think too much about it. I'm just trying to explain you at a high level. Later we will deep dive into it. But let me fix this phase one. What is happening? If I want to use phase from Langchain import in below. Not found, no module called phase. They haven't mentioned, they are saying just community will work, but this is not working. What was that? GPU. As hyphen GPU. Not find a version that's certified. So I think there is some mismatch between the different versions. Okay. So maybe we can use some other database, but that will take time. We can try Chroma as well. Langchain Chroma. Let's try this real fast. Leave it, it will take some time. Anyway, so what I'm trying to explain you is, once we have these embeddings, once we create the vector store, which will have our content in the form of embeddings. Okay, and if I ask a question like answer the following question based on the context. Okay, so that context is basically will be coming from my vector database. Okay, and if I create a chain something like this, my context which my retriever will give, whatever question I will ask, for example, who is the oldest friend of Sachin? This information was there in my document, which is Vinod Kamble is the oldest friend of Sachin. This statement will create embeddings, which will store in the vector store. And there is something called the retriever. This will help us to do semantic search in my vector store to get the relevant chunks. Okay. So when I use retriever here as my first runnable parallel, I also want to pass my question in my prompt, right? Whatever question I give in the chain, that should also be passed to my prompt. So I can simply write question is equal to runnable pass through. So what it will do, it will not do anything. It will just let this question to be passed as is. And this first will basically fetch context out of my vector database, and it will set in the context, and the value of question and context will be passed in the dictionary for my prompt. Right? My prompt is looking for two different values, context and question. Is it clear, guys? So the role of runnable pass through here is just to let my question to be set for whatever user has asked the question, let it pass through this particular first step and set it in the question P basically. Okay. So if I don't pass this one, what will happen? My prompt will throw an exception that it's looking for question, but you have not provided me the question. I just have the context. So in order to provide the question without doing any processing, I can simply write runnable pass through. Means let this question pass through and set it to the question and pass it to the next component. I know it's a bit difficult to understand or digest, but this is how it is. Okay, with practice you will understand all these things. Okay?
So something like a default kind of thing.
Yeah. I mean, you can say that. Okay, so that was on the runnable pass through. Next is your assignment. So what you need to do with this knowledge, right? We have seen a lot of things. What are runnable parallels, runnable pass through, how you can create a composed chain, chain within chains. So use that concept, and all these things you can also go and check in our this platform, whatever we have done, this coffee and everything is getting tracked. Okay. See, this is my runnable parallel. Right, I had those two different chains, right? This is chain 1 and this is chain 2 in the runnable parallel. You can see the same name, runnable parallel. It has two runnables. One is the chain 1, which give me poem. The second is the story. And if you click on that, you can see the output is in the form of poem and the story. You click on chat prompt template, you will see poem and then the final prompt template. This is the comparison basically. Okay. poem and the story comparison. So everything is getting tracked. So what you have to do in this particular assignment, that you have to write a blog post to develop a pipeline that transforms a Wikipedia article into a well-structured blog post. You can go to any Wikipedia page, let's say Delhi Wikipedia. Let's say this is one Wikipedia article. So you can just copy paste this article. And what is our aim is, with the help of, to develop a pipeline that transforms a Wikipedia article into a well-structured blog post. Let's say you are a blogger and you want to write some blog post with the, so what you can do is you can use this article and then you can build a pipeline which will involve extracting the key information, summarizing, creating an outline, and generating the final blog post. So these are some steps which are being written. Summarize each concept, generate blog post outline, how you want to create the blog post. First, you will create one chain which will create the outline for the blog post. You will create a chain which will create summarize the concepts or the contents which are there in your Wikipedia article. Then the output of both the chains will go into some final chain which will take these two as an input, and it will generate the final blog post. Content it will take from this one. The outline means how you want to write the post, right? You can create some outline. With the help of outline and content, it will generate the final blog post, and you can basically monitor or observe that particular thing in your LangSmith. हो जाएगा? And there is another assignment which I think, let's finish this one, then we will move to this one. This is a conversational chain where we will try to build an application which will basically also remember your history, right? It will have memory as well. It's a conversational. Okay, first try to do this one and then maybe we can discuss this one. Okay, good enough. Any questions, guys? You are so silent. I hope you are not getting bored.
A lot to digest, that's all.
Sorry?
A lot to digest. The digestion of all this information is not easy, but we're getting there.
Yeah. So yeah, I mean, you have to, maybe you need to revisit this video, go through the video, try these exercises. Okay, practice during the week. Maybe you can spend 1 hour on the daily basis. I think that will make you an expert. After a few days, I think these will be very obvious things for you guys. Okay, you can ping me anytime during the week also if you have any questions. Okay, I will try. Next week, we will cover Streamlit. That Streamlit will basically, right now, we have been doing all these things in the either in the Google Colab or in the VS Code, right? So if you want to go to any stakeholder, your manager or your client, you cannot just show this VS Code ID, right? You should have something, some working application. So Streamlit will basically help us to build some user interface very quickly. It's a Python library, very, very widely used in the industry. And this library is very much data oriented, data scientist oriented. So they have all those plugins which are required for us. And they have also added some chat components which will help us to create these chat applications, user and AI chatting to each other, right? So we will deep dive into the concepts of the Streamlit, and we will build one application which will have a user interface. And just like in the chat GPT, we ask questions, we can ask questions into that application. Okay, that will be exciting. Any questions, anyone, before we close? I think we are 20 minutes before our scheduled time. Any question from the previous classes? Any doubt regarding the course, expectations, feedback? Everything is welcomed. Amit, Anup, Ashok, Chaitanya, Deepak, Raghavendra, Rayan. All good, guys? Keep interacting. Okay.
Yeah, sir.
So, Surendra, there
Yeah.
is one question. So, in case like in case your applications, right, if it has multiple environment variables, so you can configure multiple Pythons, right? So, how when you are installing pip install, it always refers to which environment, so which environment of Python. So that how can you get to know when to the terminal, right? It always because when I was trying to configure this on VStudio, my environment was not that, and the brackets that you see, right? The bracket V, E, and V1. So that
Correct.
is not getting configured. So how do we set that? Or how do we configure that, right? Because I may have to do, when I try to do it, I probably have to do it through the code, not through the terminal. How when we are installing pip install.
So, I mean, what you can do is right now, my current environment is VENV1. This is my current configured virtual environment. Whatever I will install, it will go into VENV1, which is this one. Right. So if you go to the lib, whatever we installed, it's there. Right. Langchain core or OpenAI, everything get into this particular environment because right now this is the active environment which I have configured. Let's say I want to create another environment, right? So my command will be like Python -m venv, and let's say this time I want to create venv2. Okay, this Python will basically create another version, another virtual environment, and this Python is basically the Python which is right now active on my system. If it is Python 3.12, then the virtual environment which will get created will be based on Python 3.12. Okay.
Okay.
And if it is Python 3.10, then the environment which will get created will have Python 3.10. So first of all, you have to make sure you have the right version of the Python, right? So what you can do is you can simply, sorry, I just clicked enter. It will create this virtual environment with this Python. Otherwise, you can check Python -- version. What is the current version of the Python? Once you have the current, the appropriate version, then you can create your virtual environment. So this
and
is.
when you do an install, then which version it will go and install the libraries? Because right now it is pointing to V in V1. So if you want to install your libraries in the second environment.
Second, so I need to activate it. Okay, so first of all, create the virtual environment. So now you can see I have something called venv2 as well. So if I go inside that, I can see there is a script folder. So all I need to do is just give the path of that, sorry, venv2. Okay, this is the folder. Within the folder, I go to the scripts and activate. In the scripts, there is a script called activate. If I click that, venv2 will get activated. So now you can see venv1 has been replaced by venv2. And if you expand this library, there are just default libraries, just 2 libraries. Now, if I installed pip install Langchain, it will go into venv2. Okay. Is it clear?
Okay, so every time in case you want to switch over to a different environment, you always have to
Switch over
again.
Right.
Okay. Okay. Yeah.
Anyone else has any question?
No.
All right, then. Enjoy rest of your weekend, guys. And if you have anything, you can ping me today, anytime. Okay. Once I will get time, I will revert back. I hope you're enjoying sessions, guys. Any feedback for me, the way I am teaching, or anything you feel like it should be changed to some other way, the mode or.
Actually,
Yeah.
when we're trying in our company organization, but somehow I think this OpenAI or Grok, I mean, when we're trying to invoke, it's I think blocked.
It's blocked. Yeah.
Yeah.
So what you can do is you can create your own account now. You can create your Azure account. Okay, let me show you. Portal.azure.com. Go and activate your account. Even I don't use too much of it. So you can go and you can create your own account, right? So they have lots of services free for the 12 months. Okay, so if you click on try Azure for free, you create your email ID, you give your credit card, and then you should be good, right? And then you can deploy your models as well.
Okay.
Okay, you can deploy your own GPT model, and then you can invoke that model, right? So I mean, you may be able to invoke those from your company, right?
Sure, I'll give it a
Because
try.
most of the companies have blocked these OpenAI and all these things because everyone is pasting the company data into the OpenAI or the Chat GPT basically. So it's going to the Chat GPT. They are knowingly or unknowingly leaking the information, company's information, some private information of the clients, and they can put them in the trouble. So they have blocked this basically. And what they are doing is all the companies are creating their own assistants in their own secured environment. So some of the companies are creating those kind of applications which you can use internally, and that LLMs are deployed in their environment. Okay, so that it does not go outside the periphery. Okay.
Yeah. So this is free, right? Azure for free?
Yeah. So this you can enroll. You need to put some credit card details, and it will be free for
And
12
from
months.
here, we can directly call the models.
Yeah, you can. You need to deploy your model. Okay. It's very easy to deploy. Go into the Azure AI Foundry, select your model, maybe like GPT-4o Mini, click on deploy button. It will be deployed. There will be some code snippet. Just copy paste that code, put it in your IDE, put your keys, and you are good to go. If you want, maybe I will just recheck my this account, and in the next class I can show you how you can quickly do it.
That will
Okay.
help if possible. Yeah.
Yeah. You can you can use anything, right? You can also use Gemini or AWS. They all function almost same.
Sure,
Okay.
first I'll give it a try.
Yeah.
I'll let you know. Okay.
All right. Chalo, ठीक है, guys. Enjoy your rest of the weekend, and I see you next week. Thanks. Bye
Thank you.
bye.
Thank you.
Thank
Bye
you.
bye.